G'day, it's Rob here again. Well, today we're going to do a bit more work on the old Schaublin, trying to improve her a bit. So we'll get on with the job. When I got this lathe, it didn't have this pulley on it. It had the, well, not the V-belt pulley, it had the flat belt pulley, which I had to work on as well. I mean, everything was pretty rough. This is the latest edition. It came, previously I had this one on, which is slightly bigger, not much, and it had some imbalance in it, and I tried to machine it back. You can see the imbalance in it, so I tried machining it back and put it back on. It was still not right, and it looked a bit modern, I thought, for the old girl, so I dug out that old cast iron one I've got, and that had just as much imbalance in it. So that's what today's episode is, try and get rid of that. And this is the original pulley that came with it, which was way too big. The thing was geared down to hell. So, you know, I was crawling. So I've increased the spindle speed a lot, you know, compared to that. And I forget the figures on it now, but I think it goes up to about 900 RPM on the fastest, I think, and it goes down to about, I don't know, 180, I think, on the slow one, somewhere around there. Anyway, so the pulley had to be balanced, and that's what I've just done. I've finished the project. This has all been reground, but I'll show you what the steps were to balancing the pulley. I didn't actually decide to do a video on this until I got the shaft pulled out, so we'll pick up the actual balancing part from where I've got the shaft on the bench. I mean, that's the main part of the video, really. There's two ways to do this. Basically, we want to, say, balance the shaft, or make out this is the shaft, and you've basically got to have some really low drag way of mounting it so it can find its own low point or heavy position. What we're going to do is we're going to use a couple of knife edges. The alternative is to use ball races, open ball races with no seals on them, no drag, no lubrication actually, so they're free spinning, but I haven't got anything like that. I've only got sealed ball races, or really big ones. So we'll use knife edges, and I'm just going to use a couple of pieces of Dexian. That's not very straight, but this is pretty right. You want something very thin cross section, as thin as possible, so the actual shaft will roll on it easily, and that way the shaft will find its heaviest or lowest position on the pulleys, and then you can take the metal out to counteract it and hopefully balance them to a better state of affairs than they are at the moment. So yeah, that's it. Just use something, whatever you've got. This is the best sort of metal I've got to do the job. So we'll set it up and get on with it. A simple way to do this is just to mount the two pieces of Dexian or Angeline or whatever you're using across the base of a. I've just got an old Black & Decker workhorse here that I do a lot of work with, and just set them up so that they go in a position where the bushes or the bearings of the shaft would normally be. So that's your working area. Check with the spirit level. That way, that way, that way, that way. Obviously this way is the most important. Crossways doesn't really matter if it's up or down. That's not going to have much effect, but certainly you want it to be level in that position, because we'll be rolling the shaft along it to get our measurements, to see how it all works out. Right, we're ready to go, so we'll see what sort of result we get out of it. Right, well, I put a chalk mark on the pulley and we'll just move it
And it should centre itself on the lowest point. There's our chalk mark. So that's where the heaviest part of the shaft is. Basically, I think it's on this section here. So we've got an option of grinding a bit away to, our weight is down here, so we want to reduce the weight, make it even, so we can grind away, say, a bit of the spoke or some of the bottom. It's a matter of whether it's the pulley though, or whether it's the V-belt pulley, or whether it's the flat belt pulley. So what I'm going to do is I'm going to mark the shaft with text, with a texture pen or a scribe, or just measure it actually, probably the best bet. Measure the distance from here to here, and I'll take the pulley off and I'll test it to see whether it's the flat belt pulley, which is quite possible because they had a lot of porosity in it.
Okay, we'll measure the distance from the end. No good using marker pen because it's going to, pulley's coming off that way, so it will rub it. So we'll just use the old crappy old measure, 43.29. Right, so we're good to go. I'll leave the caliper set so we know how much to put it back in. And we'll take the pulley off. This is where I like these little breaker bars, cheater bars. I use this all the time because you can get into these sort of jobs really easily with them. They have a lot of frigging around and they're simple to make. Right. So the pulley's off, so now we'll try doing a check on it to see whether the actual flat belt pulley is out, because when I got this originally, this 3-step cast pulley, I mean, I'm sure it wasn't Schaublin, it was some aftermarket thing, old, but anyway. This large dry pulley here was all pocked with air holes. It had a huge amount of porosity in it. And it was that bad, there was that much air in there. It was so out of balance that I machined it off right back to this pulley level here. And you can see, if you look closely, where I've sweated on a larger steel dry pulley. I heated it up and sweated it on. And so that's steel and this is cast. To try and get some balance back into it. Also, the centre was worn from flopping around so much that I knurled the drive shaft. You can see the knurling edge there. I knurled the drive shaft to make a snugger fit, and I Loctited it on. And well, I think I Loctited it on. It's been so long ago I can't remember. But anyway, I built it up with a knurl, which is a cheap and dirty trick. Good way to go, fast. And anyway, everything seems to be symmetrical. It's just this imbalance problem. So it could be this, or it could be the pulley. I don't know, but we'll put this on and see what happens. Right, we'll see what happens.
So the pulley's got it's got a weight problem. We've got this pretty right now. It's our chalk mark and it's just trying a few different spots. I've just drilled a bit out the face of it. I mean, this is a bit hit and miss, but it's the best you can do. Just try different spots to make sure there's no irregularity in the knife edges you've got. Okay, that'll do. We'll put the pulley back on and we'll try it again.
Right, well, I put the pulley back on and I put it on in a position that I know I've got a reference point, these two holes here, line up with that grub screw there, so that if I take the pulley off at any stage I can always put it back in the same position. That way any balancing that you're doing, you keep that balancing situation the same. Otherwise if you put it back and you've been playing around with a pulley, you could throw the whole thing out. On the end we've just measured and we've got it right with our cheapy caliper. I don't use my good one on stuff like this. And once again I've tightened it up with a little cheater bar. So now we'll balance this and see how it goes. And if it needs some metal out, I'll just take it out with this grindstone, just grind a bit of the web away, and hopefully we'll get it better than it was anyway.
Alright, let's see how we go this time. Okay, it looks like that's still a problem. Try a different spot. Okay, so we obviously need to grind some metal out here. There's some weight in this here, so I'll get into that with the grindstone, take some metal off, and then we'll get it to a state where it should be better than it is anyway.
Well, I'm still grinding. It's obviously quite a bit out, this pulley, and of course when you grind with cast iron, wear a dust mask, and yeah, just working my way around. Just it's always in this one section here that's too heavy. So we'll just grind those edges away and we'll slowly take the weight off. It's getting better. I've been testing it. Just go along steadily, test it every so often. And we'll do a bit more.
Well, this is as good as I can get it. It's not bad. Just test it. Turn it around the same spot and then test it again. the better the knife edges you're using, the better the result. You don't know how flat this stuff is. That's why you always turn it around in the same spot and then check it again to see if it rolls the same way or differently. This is where I've been grinding out up here, this section here. That's the bad area. And to get it into the horizontal position and let it go. It should fall down if it's overweight. That's not too bad. Try a different part of the shaft for the knife blade just to see. See, the thing is that you could have a irregularity in your blade rest as well. There could be little ups and downs in it, but to do this, get it 100% accurate is pretty tricky. You need some really good sharp edges. You can mount the shaft in ball races and do it that way, but they have to be open ball races with no oil, so they're free spinning. You know, you can't use sealed ball races. That's all I've got is sealed ball races. So it could be just a tiny little bit that needs to come off. But oh yeah, it's pretty good. Certainly a lot better than it was, for sure. So now it's just a matter of cleaning it up a bit with a bit of emery and put it back together and see how she goes.
Well, this is not too bad, better than it was. It's pretty smooth, still a bit of vibration, but that's coming from the motor, I think. I think the armature and that's, the rotor and that's a bit out, pretty ancient. But overall, yeah, not bad, worth doing. Put her on a different speed. Yeah, that's nice. Pretty good. Low speed was never a problem before. Medium speed had a bit of, wasn't bad. I've geared it slightly faster with this pulley too. It's a little bit smaller than the other one, so that's not bad. It's pretty good. Put it on a high speed. Probably still get a bit, I think, in that though. Well, that's pretty good too. Yeah, well, it has improved it for sure, definitely. Yeah, it's a lot better. Well, I mean, it should be better because we took all that metal out of the pulley that was obviously in the wrong place. So, yeah, that's good, really good. Yeah, very good, in fact. Yeah, in fact, if you look at my light on the right here, whoops, which is bolted to the bench, virtually no shake, which is good. Yeah. Oh well, it was worth doing after all. But that's the trouble, you buy pulleys, you're lucky to get one that's actually balanced, you know. And, well, you can balance them yourself, as I showed you how to do it, with just a couple of knife edges. It's not difficult, it's just, you know, slow, do a little bit, try it, do a little bit, try it, you know. And, yeah, at the end of the day, it worked out alright. Well, that's the end of that. I suppose you could say it was slightly more interesting than watching paint dry, just. But, but at least it gives you an idea of how to go about doing these sort of jobs. And if you've got a balancing problem, you know, with your pulleys or whatever, well, it's pretty straightforward, pretty simple exercise. And yeah, have a crack at it. Okay, that's it from me. I think it's time for a beer and a bit of lunch, and I'll see you next time. Cheers.